Hi, Professor.
Yeah, hi. How are you? It's only you. What happened to the other people? Huh?
I
This
don't know,
is
but I almost didn't come either.
mhm. They're they're all late. They're all being late or just being um tardy. They just
Or-
well,
I don't know,
let's see.
maybe it's everybody's sick, Professor, because I've been sick since last week.
Everybody's what?
Maybe everyone is sick.
Sick. Why?
I've been sick since last week.
Oh, I hope it's not something serious. I could sense that because your voice from your voice I could tell, you sounded like you had, you came down with something. I hope it is
Hmm.
not something serious, especially,
No, yeah, no.
did you?
We went to the doctors, but they said it is
Mhm.
just a common flu that people are getting a lot because of the AC. So it's me
Oh
not
yeah,
work.
yeah, 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 yeah,
Mm,
yeah. People, yeah, obviously, the temperature difference between inside and outside. If you're in AC, um, air-conditioned environment, and your body
yeah.
can't just adjust, quickly enough when you go outside or something. I hope. I hope. Because are you are you fully vaccinated?
I am. I am.
Very good. Because
Mhm.
you can never be too sure. Because
Mhm.
it's it's not normal times. It's not ordinary times. Well,
Yeah.
so I see Jimena. So just two people. How are you, Jimena? Let me just make sure how many people are logged in.
I'm good. How are you?
Good, how are you? Let me just check today's forum. Okay. All right. So 7:29, that's today, and I see only now this is a disaster. And I don't understand how these people how they think they are gonna manage to pass this course. I mean, they will pass, but attending class like this, it could be a marginal pass, just marginal pass. So, all right, I'm gonna. Oh, okay, let me just organize my desk. So, all righty, we have six people, and then in the today's forum, and four people here in. Okay, so let's start with the. Let me open. Okay. Uh, I think it wasn't there. I think it is. Okay, I have all these screen grabs of the practice problems. So let me open that. And all right, it's there. And also Excel file. Okay, I'll go to find value. All right. Oh. Oh, that's interesting. What this is not. Okay. All right. How come I can't find the file? Why? Okay, just give me a few seconds. Okay, it's right there. Why isn't it opening? That's weird. All right. So I want to quickly. Um, I'm not even sharing the screen, so let me. Okay. So we're going to take a look at the examples of the problem, right? Examples of the problem, which is right here. Okay, you guys see this? Everyone, okay.
Yes.
LU to which one? All right, thank you. Thank you for the response. Practice quiz. So I already penciled in something there, right? Because when faced with these types of problems, some students can't interpret it. For example, it says complete the following without a table. I mean, don't even bother with the table. In the old days, they used to have what they call interest factor tables. And the interest factor table is actually something like 1 plus r raised to n, that part pre-calculated. But the table has limitations. Table has inevitably limitations. Why? Because I don't use tables, because we can do better. We do it directly on Excel, so we don't need tables. And the table has limitations because if the interest rate is something like 0.45 decimal places, I mean, even three decimal places, like, if interest rate is like, 14.55%, 14.455%, if that is the interest rate, then it is four decimal places because it's like 0.1455. The tables don't have as precise classification like four decimal places. I mean, at best, it's like two decimal places. Okay, so and also in terms of n, right? The table doesn't have more than 30, and that's annual. Or it's all annual, right? So it is limited. It has really, so that's why I don't use tables. But the textbook is still, if you, I, I, I'm telling you, I probably said this before, but it's the way this textbook is illustrating is rubbish. It's like, early 20th century method, using, pencil and paper. I mean, of course, that's doing math. Nothing wrong with doing math. You need to, you should be able to do the math. But the thing is, doing it on paper with pencil like that, then there's no way you can handle massive number of problems all at the same time. You have to solve each problem one by one, right? So that's why I use this book only to borrow these problems, right? I use this book because of its test bank. I mean, example bank, right? Practice example bank, not for the way, the methodology they use it. You understand? And here's the problem. Some students, every semester, I encounter a number of students who hardly attend class. In other words, they are not studying the videos provided. They don't attend the class session. They pay no attention to what's going on in class. For whatever reason, they may be working or whatever. But then, even if they are working, then, after work in their own time, they have to catch up because the videos are provided there. And I'm also even providing the session recording every day. So they can even watch that, right? They can even watch that. But they don't do anything like that. And they think they can do it by just studying the book. No. As I said, I'm not teaching you what is illustrated in the book. It has nothing to do with what I'm teaching. Okay, this class is not about doing the math. That's the math itself, the level of math itself in this book, in this course, is not that high. It's not a very, high level of math. It's just about, eighth grade math at best, right? So it's not about learning math. There's nothing more about the math to learn. I mean, there are some because algebra, and there are things that like power functions, exponent, you have learned it already actually, but you just need to refresh on that, like rules of exponents, things like that. But then other than that, the math itself is not really a big deal. So what matters in this class is how you design the mechanism, right? How you design the solution mechanism, right? How you build, how you identify the structure of the problem, right? And when you identify the structure of the problem, then um, you'll be able to design the solution process and do it, put it into Excel so it can be, automated. Whole solution process can be automated, right? Not doing it one by one, but you just enter, you have the solution mechanism there, and all you need to do is just enter the variables, input data, right? And then the mechanism is, automatically processing it, and it can be replicated uh, over over a large scale of problems, right? Think about it. How cool is that? How cool is that? Huh? But then some students, they just think they can do it by just, reading the book, studying the book, and uh, following the method in the book. I've been telling you, the method in the book is rubbish. Mhm. That's something, an eighth grader can do. So there's no point in doing what the book is, illustrating. Okay, and if you do it that way, you won't get any credit because the point of this class is not in, doing the eighth grade math. Okay, uh, but again, but of course, algebra, the math is very important part because only through math, through algebra, you can express the mechanism, right? Algebra, algebra is the only means to express that mechanism, right? So, looking at a problem like this, the first thing you need to do is identifying the relevant variables. And it is quite clear because we already know uh, a lot of things are quite obvious because this is P, isn't it right? That's P. This is T, right? Time. I don't need to rewrite it. And then bank, I think the rate of compound interest. I already know put the interpretation of that there. Rate of compound interest. What does that mean? That's the APR. That's the compound interest rate that um, that you must use. Okay, that's APR. And then what is this? Compounded quarterly. But then this is what? This is M, right? That's M. But then quarterly means what? Hmm? Some students in the past, I've seen the students, in their homework, they they enter this in Excel, they enter it like this and enter quarterly, the word quarterly there. But think about it. How stupid is that? I mean, using the word quarterly, because Excel cannot think, if you think about it, quarterly is that data? Hmm? Is quarterly a data? Is quarterly a data value? Can anyone answer that? Is quarterly a data value?
No.
No, it's not. What is the data value? What do you need to put in there? Under M, what do you need to put in there?
Um, 3/12.
No, why 3 over? Yeah, but look, 3 over 12 is one fourth, right? 3 over 12 is one fourth. But what is the what does this mean? If it is compounded quarterly, does it get compounded one fourth of a time only?
It gets compound calculated 4 times a year.
4 times a year, yes. That is the interpretation. You should, in other words, if it is compounded quarterly, that means it gets compounded 4 times a year. Make sense? Okay, and so who was that who said that a while ago?
Monique.
Monique. Okay, so today is 29th. Yes, Monique, you got it. Um, so you got 0.25 for that. Yes, you got to enter 4 there. Why? Because 4 is numerical data, quarterly is text, right? Quarterly is a text. Now think about it. Excel cannot operate on a text. You understand? No matter what you do, you enter quarterly. How is it going to be used? Excel cannot do anything with the text, right? You cannot multiply a text. You cannot subtract a text. You cannot divide by a text. You cannot raise to a text. They are not numerical values. You have to give it the numerical value interpretation of what the text is. Okay, you understand? Everyone? Everyone, did you understand that?
Yes.
Yes.
Okay. It looks like only one person. All right. So it has to be a numerical data all the time. If it is not numerical data, it's not going to work. And then, what is the number of periods to be compounded? Of course, that is n. Okay. So part A, the number of periods to be compounded is then t times m, right? What goes in here? You do it by doing t times m. Right? And total amount, that's actually future value, right? This is the future value. So just build in the formula there, future value formula, right? And and the total interest. What is the interest? I mean, this is very easy. I mean, we've done this from chapter 10, from simple interest. So this is I, isn't that right? So this is I. So then, what is total interest? I mean, what is interest? Isn't that easy? What is the, how do you find? Look, we found future value already. Then how do you find interest only? Anyone? It's almost like back to square one. Huh? When you know future value, you can find the interest. It's not only future value, you know something else too, so you can find interest. How do you isolate interest only?
Future value minus principal.
Yes, of course. Yes, of course. I think I cannot write anymore because I don't think there's any. Oh no, what did I do? This is crazy. Okay, anyway. And who was that? Who said that?
Hannah.
Future value. Hannah, okay. Hannah, so you get 0, 0.25. My God, I'll have to. Oops, suddenly, what is wrong? I'm not. Oh, I see. It's already like printed, so I cannot write on it anymore. Oh, that's a stupid thing. It doesn't allow me to do that. Okay, let's see if I can do that here. Yeah. Minus P, right? And then let me see if I. Oh! Why do I keep doing this? But you get the idea. I keep, I try to use the eraser, and then I accidentally press. I keep pressing that thing. So I think we are almost, that's not a difficult thing. We are almost. Oh, I cannot erase the whole link. I don't want to do that. I just want to erase this thing. Doesn't work. Alrighty. I can't, spend too much time on this, so we're gonna. Having now having on this. Oh, okay. So it's closed now. And now let's think about the next problem, and is solve the previous problems by using the compound value in table. Don't use the table, so you don't need to do this. For number 2, well, you can simply replicate. You can simply redo number 1. And number 3, Lionel Rogers deposits $6,000 in Victory Bank, which pays 3% interest compounded semi-annually. Now, how much will Lionel have in his account at the end of 8 years? Now, this is verbal, right? I don't know why this thing is always looks bigger when I open it. But you already, the question is, we need to identify the variables, input variables, we need to identify. So this 6,000 is, what is this 6,000? Can anyone? I mean, I don't like the silence, for 5 seconds. But this is not even a challenging problem. Can anybody tell me what this is? 6,000 is, what is this? As an input variable, what is this? No one? What did you say? Someone said?
The principal.
Principal. And who was that?
Muhammad.
Muhammad. Okay, Muhammad. So you got, it's not a really difficult, you got 0.25, which pays 3%. So it's obvious. This is, APR, right? It says interest. And this is, and I've been telling you, interest is always expressed, or any rate of return is always expressed as annual. So it's APR. And it says compounded semi-annually. So what does this mean? Compounded semi-annually, that means what is this variable? What variable does this fall into? Anyone?
M.
M. M or N? Is it M? M as in Mary or N as in Nancy?
Yeah, M as Mary.
M as in Mary. Yes, this is M. And if it is, okay, if it is semi-annual, what is it? What's the number? What's the numerical value? What is M then? It's semi-annual, so what is M? Anyone? If it is semi-annual, what is the value of M? Why does it take so long time? Do you understand? If you're dragging, if you're not instantaneously responding, like like a touch and go, I feel like a very sensitive machine, a sensitive mechanism, or you just slight touch and it goes off right away. And I like that kind of reaction. This is like a sloth. You know what sloth is, right? You touch the sloth, it doesn't move. It takes a lot of time, very slow. And I don't like sloth. What is M? What is the numerical value? If it is semi-annual, what is M? Anyone? If you're taking more than 5 seconds, if I don't hear any response within 5 seconds, I'm gonna take off 0.25 from everyone. You understand? There should be, if there's a positive incentive, there should be also a negative incentive too. For underperforming, there should be penalty. So anyone?
Is it 6?
6? Does semi-annual compounding mean 6? Think about it. If it is 6, that means compounding frequency per year is 6. But then if compounding frequency per year is 6, then does that mean every 2 months? Semi-annual means what?
Every 2 years?
Every what?
2 years?
Every 2 years? No, every 2 years is biennial. Biennial. Okay? Semi means what? What does semi mean? You guys don't even have the, basic common sense of what does semi mean? Should I apply penalty to everyone? What does semi-annual means what? Okay, I have no
Every
other
six
choice.
months.
Every 6 months. Okay, who was that?
John.
John. Okay, thank you, John. You saved the rest of the class from penalty. Yes, every 6 months. Then that means how many times a year? If interest is compounded every 6 months, then that means how many times a year?
Twice.
Twice. That means 2. Right?
Yeah.
Isn't that right? So everyone thank John, please. He spared you from the penalty. Spared all of you from penalty. Huh? So and then so what's he gonna have in his account at the end of 8 years? That means T. That's T. T equals 8, right? But then here we need okay. If you said 6 semi-annual means 6. Think about it. If it is 6 times a year, then compounding is done. That means compounding is done every 2 months. If there is that kind of compounding, I would really love it. But then, no. Half year, right? Every half year, compounding happens. Semi means half, right? So now, when we set it up, another thing you need to once you identify these variables, then input variables, then next question is you have already the design, you have the problem design in your mind, solution, design of the solution already in your mind. Of course, it's going to be, we'll have P, we'll have APR, we'll have T, we'll have M. Excuse me a second. So then think about it. Because compounding frequency M is 2, we need additional variables, which is R, and then we will need this will get us we'll need to have R and N, right? And to find effective interest rate, now we're coming to effective rate again. Remember effective interest rate, right? From simple discount. Does everyone remember effective interest rate from the simple discount?
Yes.
No? Yeah, thank you. So effective rate is actually, remember that is, it effectively in the simple discount rate is 10%. If they say discount rate is 10%, it looks like, oh, because the simple bank discount or simple discount is the interest you pay up front. 10%, if you're paying 10%, if you're, if they're using 10% discount rate on $10,000 note, you're paying $1K upfront as interest. But so you think, oh, so I paid 10% interest, but actually no, you paid because for receiving 9,000, you paid 1,000 as interest. So effectively, you paid 11.11% interest. So just like that, in compounding, there's also effective interest rate. Effective interest rate currently in this problem, principal 7,000, interest rate 12%, compounded quarterly. That means M is 4, right? M is 4. It's not 1/4. M is 4, right? Because every 3 months, so 4 compoundings per year, right? So if compounding M is 1, in other words, if compounding is just annual, then it will be 12%. But if compounding frequency is greater than 1, then effective rate will deviate from given interest rate. So in other words, effective rate, there's another name for effective interest rate, which is called APY. And APY is different from, it's not equal to APR. Okay? So we know what APR is. Okay? APR, this is APR, right? This is APR. And everyone knows what APR stands for, right? Can anyone tell me what APR stands for? Is there no one who knows what APR stands for? What does it mean? Okay, counting 5 seconds. If there's no one, then you will get
The annual percentage rate.
the annual percentage rate. And who was this?
Monique.
Monique. All right. Everyone, please thank Monique, because Monique spared all of you from penalty. Okay, Monique, you got 0.25 for that. Yeah, if APR is annual percentage rate, what do you think is APY? What do you think that stands for? Of course, A would be annual, P would be percentage, of course. Then what is Y?
Yield.
Yield, yes, stands for yield. And who is this? Monique again?
Monique.
Okay, all right. So you got additional 0.25. Okay. So now we are pretty much, familiar now, pretty much familiar with the setting or the structure of the problem, right? Number 5, calculate. Don't use table, even though, no matter what the problem says, even if the problem says use the table, there's no table. I mean, the book may have, but don't ever use the table. That's rubbish. Okay. That's really a stupid thing. Because there's a lot of limitations, right? So calculate what is 1,500 compounded daily. So now you should be clear. This is P, clearly. Compounded daily, that means M is what? If compounding is daily, what is M? Anyone? If compounding is daily, how many compoundings occur during a year, per year?
365.
365. And who was this?
Monique.
Monique again. All right. Okay, Monique, you got another 0.25. And then for 5 years, of course, that's T, right? And growing at 7%, that's APR. So just like, okay, then we know, oh, this will require also, right, or we need additional, additional variables like r and n, okay. Alrighty, so with that in mind, let's do the, okay, let's do these problems, okay. So I'm gonna, okay, I'm gonna have to, since we built this yesterday, and we don't, don't need to, okay, I'm just gonna insert new rows because we need like 5 rows. And then there was one more thing. There was one problem about effective interest rate. I'll put it there. There was one problem that was asking for effective rate, right? So I'm gonna get to that later. Here's the thing. So I'm not gonna. You forget about it for now. And we're gonna also do it in 2 ways. Okay. So I'm gonna. I'll just. In the homework, I've noticed that people have done the problems in um, by the learning units. In other words, if it is LU 10-1A, then they used one model to do all 10-1A and didn't indicate problem numbers. But normally I would indicate the problem numbers. I would indicate each problem by problem number. So this one is number 1. So in the column A, normally I put, okay, just that's what I would normally do. Okay, so this is 12-1. I'm doing LU 12-1. And another thing, the instruction was very clear. Okay, there's certain font. There's designated font and font size. And I'm sure you all. So for example, in the announcements, not there yet. You see this all All works must be done exactly in the order of the problem listed below. Use absolutely Times New Roman or Georgia font with size above 14 only, right? And I repeated that, how to name your homework file. This was also emailed out. And some people did this, some people didn't. But of course the majority did this, and they followed this. But there were some people that didn't follow this. There will be penalty for not conforming to the designated style, the uniform style. It has to be uniform, okay? And also there's a reason, you see, as I'm doing this, okay, you're looking at the Excel file now, right? Are you?
Yes.
Okay, thank you. And you may have noticed I magnified, I zoom in, so it's, I zoomed in to 150%, so it's magnified. But even if it is at 100%, even if it is not zoomed in, it's already a very decent, large font. But I can see this, but when it is projected on your screen, it may not be that visible. It may not be large enough. So I'm always using zooming in to blow it up, so that it will be of decent decent size, and so it is clearly visible. Also, when you submit the homework, it must be at least size 14, and think about it. The default font in Excel is something like Arial, and that is very unappealing. And I have to grade a lot of people. I mean, this is summer. I have, the class size is very small, but during the regular semester, the class size is at least about 30. And when I deal with, students' homework, if the font size is small, of course I can, blow it up, but it's annoying, and it's very tiring to my eyes. Small font size, it's very difficult to see, and the default Arial font is so dull. It's so dull. I mean, one reason people get thrown off when they are dealing with numerical data. I mean, when you download the data, it's in basically in that size 10 Arial size 10 font, and it is very dull. It's very dull. It's unappealing. You don't want to deal with that data. It turns you off. Simply, it turns you off. So I try to at least turn the spreadsheet into something that I don't mind looking at. Okay, if the font is more aesthetical, I don't, if the font is more aesthetical or more, it's more appealing, right? And if the font size is decently large, I feel less overwhelmed. If the font size is too small and there's tons of data in a very dull, unappealing Arial font size 10, I feel overwhelmed. Not just overwhelmed, but also I get turned off. I don't like to work with that data set. So that's why I designated Times New Roman or Georgia font, right? Size 14 or above. Okay, so anyway, so let's do this. The number one, principal 200, 1 year, 8%. So that's 200, 8%, 1 year. But then what is the, and since we already worked this out yesterday, the formula is already in there. You don't have to do anything again, all over again. So compounded quarterly, right? Compounded quarterly. So 4, did I enter 4? 4. There you go. You get it already. And then number 2. Number 2 is actually doing this by table, but you don't have to do it by table. So I'll just, drag it down like this. Again, when you drag down the entire row, then it adds 1. So be careful not to, it just mechanically adds 1. But you're human, you control the machine, right? You control the machine. So if machine does that just mechanically, you should be the one. I mean, you're eventually at the last line of defense for your own work. You have to examine it. You have to inspect it. You have to inspect it and make sure that everything is, everything stands to reason. Okay. And the next one, it says $6,000, 3% APR, 8 years, M is 2. 6,000. Oh, 8%, right? 6,000. Oh, 3%, 8 years. 3%, 8 years, semi-annual, right? Now, again, we'll take care of the rest, later. We'll just enter the input data. Input the data there. Number four. 7,000, 12%. 4 M is 4. How many? It's just 1 year. I mean, there's no year, so it's just basically 1 year. And question is, the main question is about APY, effective rate, not future values. But so we just for APY for that problem, 1 year, 7,000, 12%, right? Compounded 4. 7,000, 1 year. Oh, again, I forgot. 12%. Wow, that's monthly. That's even 1%. That's actually, compounded quarterly. And then number 5 was what? Number 5, 1,500, 7%, 5 years, 365. $1,500, 7%, wasn't it? 5 years, 365. Let me just verify. So 7%, 5 years. 7%, 5 years. 7%, 5 years. 365. Okay. Now think about it. Once you have set it up like this, then all you need to do is simply just copy and drag, right? Because it's the same formula. And here what we did was the formula we used was this, right? So everyone is okay with that? Everyone? Are you sleeping? Did you
Yes.
guys fall asleep? Okay. So you're okay with this. Everyone is okay with this, right?
Yeah.
So, yeah, good. So because our formula is correct, as long as our formula is correct, and you identify the structure of the problem, so you entered the input data uh, correctly according to that structure, and then the solution cell is, basically the same thing. You just drag it down. Okay. Now, again, I'm gonna do it in a different way. It's not a different way, actually. Uh, it's not different, but just I just want to make it. Um, okay, so it's the same data, right? You see, what I did was basically I made it equal to that cell, that two, and then you drag it down, you automatically the same thing happens. So here, what I'm trying to do is, okay, instead of using this formula, right? Because in this formula, the adjustment is made inside a formula, but I don't want to. I want to make it simple. I mean, I made adjustment outside the formula, right? So that the solution cell can be simplified. And then I told you I explained about the benefits of doing it this way. Yes, I already explained this yesterday. I said um, the benefit is when something goes wrong, you can easily identify the source of the problem. And when you can easily identify the source of the problem, you can easily also fix the problem. But if the solution cell is more complex, then it takes more time, right? It's more difficult to identify the source of the problem. Okay, so um, and then think about it. Once we got this, all you need to do is simply dragging it down, right? Okay, everyone is good. Um, and if you have already, how many of you have this file opened in front of you? When we
Yes.
do this, you must, okay, at least one person. And who else? Who
Yes,
else?
we have.
Okay, good. So when you have this open in front of you, please, you must also uh, replicate what I do, right? You must also replicate what I do. Um, that's the point of this exercise. You do. So did everyone? I'll give you a couple of. Oh, okay. Before that, hmm, okay. I'll just give you a couple of minutes. It's 4:09, so I'll give you 5 minutes to replicate this. So 6 minutes. So uh, you work on it on your own, and we will reconvene exactly at 4:15, and then tell me if you got the same result. Okay, we'll confirm. All righty, we'll take 5, and All right, we're back. We're back. Mic stopped working. Okay, Mohammed, sorry. Whatever, you gotta check your audio system, especially your microphone. All righty. So did you guys do it? Did you guys complete this? Are you there? You guys are back? Are you guys back?
Yeah.
Okay, good. So let's see. Did you get the same result? Let's see. First, did you get this? Did you get these results?
Yes.
Okay, so you got it right then. That was also copied. That the ink thing was also controlled. And what about this? Did you? It's basically APR. Oops. Divided by m, and this is t times m. And the future value, of course, obviously, it's p times 1 plus r times n. Oh, no, what am I doing? 1 plus r raised to n, right? And then 3 of them all together, dragging it down. So everyone got the same result?
Yes.
Yes.
Okay, thank you. But we're not done yet. Why? Because one of the problems, I think it was, number 4, find the effective rate, APY. So here, what does APY do? What does that mean? So let's take a look at this example. Okay. Let me delete everything here. Okay. Suppose you're putting $1,000, right, at 6% in a bank at 6% interest rate for 5 years. This can be, let's apply all possible scenarios. The scenarios are basically varied by M. So M can be 1, which means annual, right? 2, which means semi-annual. 4, quarterly. 12, monthly. 52, 52 weekly, right? 365 daily. And is there any more frequency than daily? Yeah, theoretically, you can do compounding by the hour, right? Also compounding by the minute, compounding by the second, or compounding by nanosecond, right? Theoretically. But actually, they don't do more than daily compounding. That would be the maximum. But theoretically, if you're compounding by the hour, then all you need to do is 365 times 24. You just multiply 365 by 24 because daily 24 hours, right? And times 365 days a year. If you're compounding by the minute, think about it. 365 times 24 times 60, right? 60 minutes in an hour. And then if you're doing it by the second, that 365 times 24 times 60 times 60, right? 60 squared, right? Which is theoretically possible, but they don't actually use it, right? Nanosecond. By the nanosecond, what is nanosecond? Nanosecond is What does nano mean? You must have heard of the word nano a lot of times. What does nano mean? Does anyone know what nano means?
No.
Okay, but haven't you heard the word term nanometer, nanosecond, nanotechnology? Nanotechnology is actually very minute, precision, high precision technology. It's nanotechnology. Why? Nano means actually 9. What does that mean? 10 to the negative 10. 10 to the negative 10. 10 to the negative 10th power. Okay. Okay, 10 to the negative 9. I'm 10 to the negative 9th power. So, what is 10 to the 9th? Anybody? 10 to the 9th. It shouldn't take even, it shouldn't take even 5 seconds. We know 10 squared is what? 10 squared is what? What is 10 squared? You can't even answer that. I'll have to apply, penalty to everyone. What is 10 squared? Okay, there's no
1,000.
no. Huh? Someone said what? You already said that. Say it again. Why take so much time? Someone said something. What did you say? And who said that? If you said something, you have to be you should own it. You understand? You should own it. Who was that? Who said? Was it Mohammed? Someone said something. Mohammed has yeah. And this is okay. 100. Yeah. 10 squared is 100, of course. And then 10 to the 3rd power. What is 10 to the 3rd power, or 10 cubed? Huh? Basically, it's a matter of just adding zeros, right? 10 squared is 100. And what's happening with the rest of the class? Are you all dead? Yeah, of course, 1,000. Huh? 10 cubed is 1,000 because it's 10 times 10 times 10. And if you extend it like this, we can understand. 10 to the 6th power is 10 to the 6th power is what? 10 to the 6th power. Nobody's answering, huh?
100,000.
10 to the 6th power is 100,000.
Oh no, it's a million.
When there are 6 zeros, 10 to the 6th power means 6 zeros. 6 zeros mean you guys are really, you guys are amazing, huh? You don't look. First of all, let's start with 10 to the 3rd. This gives me. And this is a common sense thing, and this makes your life a lot. This makes your life a lot easier, but a lot of people don't even have this concept. 10 to the 3rd is 1,000. And remember, we don't just put 1 and 0, we put comma there, right? Why? Every 3 zeros, after every 3 zeros, we put comma, because this is where the word changes. This is where the name for the word changes after every 3 digits, right? So 10 to the 6th, you gotta say it because I can, if you type
1
something into
million?
the chat box, I can't see because I'm looking at
1
the
million.
Excel. Huh?
1 million.
1 million. And think about it. 6 zeros, 1 million, right? Now, what do you see here? Another first comma, second, another comma, right? And then think about it. Before 10 to the 6th, I mean, if it was 10 to the 5th, five zeros only. How many commas are there then? Only one. But then what is that called? 100,000. Where this first comma is, then the name changed to 1,000. And then until the next comma, the name is still 1,000. Isn't that right? It's 10,000, 100,000. And then after this comma, then when we have 6 zeros, after this comma, it's 1 million. You see that? When you put commas there, and commas are put every 3 digits, that makes your life a lot easier because you don't have to count zeros. You can just look at the comma and you can tell you know what to call it. But then think about it. 10 to the 8th, what do you think it's going to be called? 10 to the 8th. How many zeros does it have? How come nobody's answering? Hannah, how many zeros does it have? Huh? Who said that?
John.
John?
Yeah.
Okay. Yeah, 100 million. Now, I'm afraid, this is simply counting numbers, so I'm not gonna, you didn't earn a point, but, thank you for answering. I mean, this is not elementary school. You don't get points for counting numbers, right? Yeah. Oh, that was 100. Okay, we have 2 commas, so still million, and just 100, so 100 million. And then what is the 10 to the 9th? What is the 10 to the 9th?
1 trillion.
Yeah, 1 trillion. And how many zeros?
9 0.
How many zeros? 9 zeros. Is someone speaking to me, or is it just the background noise?
That was my background noise.
Oh, okay. You may mute your microphone for a while there's a background noise. You see, now the unit has changed. The unit has changed. Another 3 zeros and another comma, right? The unit has changed. Now it's 1,000, million, trillion. Okay, so 10 to the 9th is 1 trillion. Then until the next unit. And actually, I'm not sure what's the next unit. Um, 10 to the 12th, 10 to the 12th, right? There will be 1,000 trillion, and then the word should change, but I don't know what is the word for that. 10 to the 12th. I don't know what is the word for 10 to the 12th, but we just call it 10 to the 12th because there's no word for it. There must be a word for it, but I just don't know what that word is. So then what is 10 to the negative 9? 10 to the negative 9. First, what is 10 to the negative 1? What is 10 to the negative 1? Anyone?
10.
Oh, 10 to 1. 10 to 1 is 10, right? 10 to 1 is 10. It's just 10 itself because,
So it's negative 10.
no, if it is negative 10, you would say negative 10. I mean, look, 10 to negative 1 is 1 over 10. Okay? Then 10 to negative 2, 10 to negative 2, that should be what?
2 over 10.
Why is it 2 over 10? If it is 2 over 10 is this. This is 2 over 10. Can't you make a connection if 10 to 1 is just 10 itself? 10 to negative 1 is 1 over 10. So that's reciprocal, right? Basically, x to negative 1 is 1 over x. It's the reciprocal. This is just basic algebra, very basic algebra. Now, what about then what should this be? 10 to negative 2, what should it be? No idea? Let me appoint someone. Hannah, are you there, Hannah?
I'm here.
Hannah.
Yeah, I'm
Okay,
here.
Hannah, what do you think this is? 10 to negative 2.
I like to. I don't know if you say divided by 10, but the line you made over as the same over that you did before.
So what did you do before?
As same as you did, like 1 divided by 10. It's 2.
And then is that right? Okay, and is that it?
No,
Is that it?
no. I mean,
Then what is it?
I meant 2 instead of 1.
Okay, so 2 instead of 1. So where does that 1 or where does that 2 go to?
Where you wrote the 1, it should be 2 instead.
You mean
No?
this should be 2?
Yeah.
That should be 2? Then you're saying this. I already said this is wrong. Someone said 2 over 10 and I said that's wrong. Well, I must consider a penalty for wrong
Is
answer.
it 1 over 100?
Okay, say that. Who said that? Please enunciate. Is 1 over what?
Jimena, 1 over 100?
1 over 100. Yeah. In other words, what's 100? 10 squared.
Mm-hmm.
is simply 1 over 10 squared. So if x to the negative 1 is 1 over x, then x to the negative 2 is 1 over x squared, right? And extending this logic, right? Then x to the negative n, x to the negative nth power, it should be what? 1 over x to the n, right? Does that make sense? Does that make sense or not?
Yeah.
Okay, good. So, and who was that who said, 1 over 100?
Me, Jimena.
Say out, me? Who is me?
Jimena.
Please enunciate your name. Huh?
Jimena.
Jimena. Okay, Jimena. All right, Jimena. So you'll get 0.25 for answering that. All right. So now let's think about it. So that means 10. Therefore, 10 to the negative 9th is what? 10 to the negative 9th. Come on, guys. Anyone? 10 to the negative 9 is what?
1 over 10 to the 9th.
1 over 10 to the 9th. Yes, 1 over 10 to the 9th. Or 10 to the, since 10 to the 9th is 1 trillion, right? It's 1 over?
It's 1 billion.
10 to the 9th. Oh, 1 billion, I'm sorry. 1 billion, right? Yeah, 12 zeros, that's 1 trillion, right? I'm sorry, 1 billion, right? So the if you say nanosecond is what? Nanosecond is 1 billionth of a second. It's a very infinitesimally small time, right? Of course, it's only in mathematical and scientific experimentation. That's the unit of time that is being used for mathematical and scientific experimentation. But when they say nanotechnology, what does that mean? I told you it's a very high precision technology. And so nanotechnology means, the precision level of, margin of error. Margin of error is like, 1 billionth, right? Now micro, when they say microsecond or micro something, that means micrometer. What does that mean? That's 1 millionth. Micro is 1 millionth, but nano is 1 billionth. Right? Makes sense? So the reason I'm talking about this is because beyond 365, beyond daily compounding, what is the level of, what is the degree of precision can we go to? It can extend indefinitely. It can be, 1 billionth of a second or 1 billionth of a day, it's not, but so in other words, that frequency per year, compounding frequency per year is theoretically, it can be even to what is this symbol? What is this symbol? Anyone?
Infinity?
Yeah, and who said that?
John.
John. So you got 0.25 again. Yes, that symbol is infinity. So that means compounding frequency per year can be infinite. That means, more than, 1 billion, more than, 1 trillion. It can be, if you divide 1 year, if you divide one year by 1 trillion, 10 to the 12th, 10 to the 15th, 10 to the 18th, 10 to the 21, no matter what, you can, if you divide 1 year by infinitely large number, it will become an infinitesimally small segment of time. Make sense? But we're gonna get to that later. But here's one another question. So why is this? Why is 10 raised to 1? Why is anything raised to 1 is self? In other words, well, maybe you just memorized it before. You just this is so difficult. Maybe you just memorized it before, right? But the general rule is that if you memorized it, here's the reasoning behind. Now think about it. When x raised to 1 is just itself. Why is it so? Why? Well, let's simply think about it. Suppose we have 10 squared, okay? And then let's say 10 raised to negative 2. Okay? Suppose we multiply these. What's it going to be? If you multiply 10 squared by 10 to negative 2, what does it become? Anyone? Five seconds. I hate 5 seconds. Silence for 5 seconds. I hate it. You will all get penalty if there's a silence for 5 seconds. You'll all get penalty. Does anyone know 10 squared times 10 to the negative 2? What's it going to become? All right, you'll all get.
It's gonna be 100.
Which one is 100? I mean, this result is. Huh?
No. It's gonna be like
What is 100? What is 100?
Oh, okay.
And was it John?
Is it 1?
1.
Yeah. Oh, who said 1? Who said 1?
Jimena?
Hannah?
Jimena?
Jimena?
Yeah.
Was it Jimena? Yes.
Yes.
Jimena. You got so Jimena. You mean the product, the result is 1. Is that what you said?
Yes.
John?
Yes, that's what I said.
Hannah, did you say yes? Okay, so this is 1. Okay. John, could you mute yourself? Yes. Why? So Jimena, you got another 0.25 because we know that's not. There's no it's 100, and what is this? 1 over 100. What's going to happen?
They cancel out.
Cancel out. So it becomes 1. Right? Also, you don't have to even, it's the 10 squared times, what is 10 to the negative 2? 1 over 10 squared. Right? Anyway, they will cancel out. Therefore, 1. Right? And then the rule of x to the 1 is the rule of, and you might remember, x to 0, x raised to 0 is what? X raised to 0 is what? What is x raised to, anything raised to the 0 power? What is it? Anything raised to 0 power? Anyone? Anything raised to 0 power? Anyone? Hmm?
Is it 1?
Yeah, yeah. And who said that?
Jimena.
Jimena again. So, okay, you got another 0.25. And why? And you just memorized. You just memorized so far. But why? This is why. Remember, the rule of exponent is when you have x raised to a times x raised to b, what do? This is the rule of exponent. X raised to a times x raised to b is what? What do? Anyone? Anyone? Jimena, do you know x to the a times x to the b? All right, there's no penalty. It's just, but you should know this is something even the 8th graders know. It's x to a plus b. Why? Do a simple experiment. 10 squared times 10 cubed. What is it? Think about it, just 100 times 1,000. It's 100 times 1,000. So what is it? Isn't that 100,000? Is everyone asleep? Why is it so? Why is there such a like a cave, hollow cave? Hundred times 1,000. Isn't that 100,000?
Yes.
Yes.
Yeah, yeah. Okay, okay. So it's not a hollow cave. At least some people are there. Some presence, human presence there. What is 100,000? 10 to the 5th. Isn't that right? 10 to the 5th.
Yes.
Hence this rule holds, right? Same base, different exponent. It's basically 2 plus 3, right? The exponents, if it is, right? So think about it. Then the same rule applies when it is, x. Okay, before I do that, let's do this. So if I do 10 squared times 10 to the negative 2, what does it become? Applying the same rule, 10 to the 10 squared plus negative 2, which is this, right? And then which is 10 to the 0. Isn't that right? And anything raised to 0, and 10 to the 0 is 1 because anything raised to 0 is 1. Why? Because if I can rewrite it like this. That's 10 squared times, what is this? 1 over 10 squared, right? Then what happens? They cancel out. That's why it becomes 1, which is, right? 10 to the 0. In other words, the rule is why this is x to 0 is 1. Think about it. You're multiplying x raised to a power, 8th power, times x raised to the negative a. Then what is it? X a minus a. That becomes x0, x to the 0, x to the 0 power, right? This is exactly what? X to the a times 1 over x to the a, and they cancel out. So what does it become? X to the 0 or 1. Is it clear to everyone?
Yes.
Yeah.
Okay, all right, thank you. So now we are a little more confident about the exponents, right? So then let's do this. So we have, what's the time? Okay. So we know what to do here. You will see that it's the same scenario, right? Same principle, same APR, same time, same number of years, but compounding frequency is different. They will, and you can understand, the higher the compounding frequency, the greater the future value. It's not right? They won't be the same. Won't be the same future value. Okay. And then, of course, p times 1 plus r raised to n. Okay, and I'm gonna drag it down all just down to here. What do you see? What do you see there? You can tell this is greater than this is greater than this. Of course, when compounding is daily, compounding frequency is daily, compounding is daily, you get the highest future value. Okay? You may say between weekly compounding and daily compounding, the difference is not very significant. It's only about 20 cents difference, but comparing that daily compounding with annual compounding, there's about $10 difference, right? $10. I mean, anybody. I mean, you might simply say, I don't care that much. I mean, $10 to me is not a big deal. 10, but rationality is always the which one would you prefer? Would you prefer daily compounding, or would you prefer annual compounding? Which one would you prefer? Huh? Tell me.
Annual compounding?
You prefer annual compounding? Who said that?
Hannah?
Who was Hannah?
Yeah.
Yeah, Hannah, why would you prefer annual compounding?
Because it's less.
But if it is less, why would you I mean, if you put yourself, I mean, you put $1,000 in the bank, right? 5 years later, this will be the amount in your account. Would you prefer to have less
Oh,
amount?
no, the other one.
Yeah, of course. I mean, think about it. If you are the one lending money, I mean, if you're the one borrowing money, of course, you would prefer. But if you're the one lending money, right? If you're putting money in the bank, you would prefer, even if it is $10 difference. I mean, some people may say, to me, $10 is nothing, but still, it's the rationality, isn't that right?
Yeah.
Rational person. I mean, it's a rational behavior to prefer, even if it is just $1 more. It's a rational behavior to prefer, right? It's a rational thinking to prefer, even if it is $1 more, right? So that is, and then if you think about it, um, so that means even if we have same input data, even if we have same initial input data, depending on the compounding frequency, right? We have different future value, and the higher the compounding frequency, the greater the future value. This is preferred, of course. And our next question is, okay, what is the effective interest rate then? APY, annual percentage yield. So we're almost out of time. So we'll have to do this tomorrow. But the idea is, if you, when compounding is just annual, APR is exactly the same thing as APY. In other words, the given interest rate, stated interest rate, is exactly the same effective interest rate. But you might wonder, it is effectively not 6% that takes you here, because if it is 6% a year, it should be this. But what kind of annual rate? What kind of annual rate? If there is no multiple frequency, in other words, if there is no if the compounding is not like this, if it is all just once a year, if the compounding is just once a year, what kind of APR would take you here? Right? Do you understand? If this is not daily compounding, but just annual compounding, 6% won't take you to this amount. 6% will take you only to this amount if it is annual compounding. So obviously it will be something greater than 6%, right? Compounded annually, right? Just once a year over 5 years, right? It would have to be something greater than 6% that will take you there. So that is the concept of APY. In other words, the rate that effectively, the annual rate that will effectively take you to this future value, right? Without multiple compounding, but just through just one compounding a year, right? So obviously it will be 6 point something. It will be, everything will be greater. This one will still be 6%, but everything will be slightly greater than 6%. That's effective interest rate, or APY. All right, that makes sense. We're gonna continue tomorrow, and for now, so I will stop recording